This video is going to go over the topic 3 test review. So for the first question, we are told that P varies inversely with X. If P is 15 when X is 3, they want us to find the value of P when X is 5. So if it varies inversely, that means that the product of the two variables is constant. So that means that 15 times 3 is the constant of variation K. And so that means that K is 45 for this problem. And then if I want to find the value of P when X is 5, the equation that we use is always that P equals the constant of variation. So in our case, 45. So whichever variable we want to know equals the variable we know as the divisor of the constant of variation. So since our constant of variation is 45, X is 5, P is going to be equal to 9. For question 2, they're asking us to identify the types of functions that the following equations represent. Some ideas of types of functions are like linear, quadratic, exponential, cubic, and inverse variation. And so when we're looking at a function to determine what it is, so if I have y plus x squared equals negative 2x, if I were to solve this for y, that would give me y equals negative x squared minus 2x. That's a quadratic function. Similarly, if I were to solve y over 2 plus 2x for y, if I were to subtract 2x, I would have y over 2 equals negative 2x plus 6. I would have to then multiply everything by 2 to get y by itself, so that would give me y equals negative 4x plus 12, so that would be a linear function. Xy equals minus 7 equals 0. If I were solving this for y, I would add 7, which would give me xy equals 7, and then I would divide by x. So that gives me y equals 7 over x, which is inverse variation. Luckily, D is already solved for y, so notice that looks just like C does, so that is also inverse variation. So we should be able to solve an equation for y, look at it, and know what type of function that represents. For question 3, we are describing the transformations needed to translate the graph of y equals 1 over x to the graph of 1 over x minus 5 plus 4. So remember that we're thinking about transformational form, which would be y equals 1 over x minus h plus k. So looking at this, according to our equation that we were given, h is 5, which means that it's going to the right 5, and k is 4. That didn't change color. K is 4, which means it's going up 4 units. So the transformations of y equals 1 over x to y equals 1 over x minus 5 plus 4 is that it's moving to the right 5 and up 4. Question 4 is asking us to simplify each expression and identify the domain. So when I'm simplifying an expression, I want to factor and reduce. So identifying x squared plus x minus 42 and x squared minus 2x minus 24, I have to do a product sum chart for each of those to determine what the factors of the numerator and denominator each are. So the numerator has an a of 1, a b of 1, and a c of negative 42. So a times c is going to be negative 42. And b is 1. So I want two numbers that multiply to negative 42 and add to positive 1. And so those numbers are going to be 7 and negative 6. So that means that I can factor the numerator to be x plus 7 times x minus 6. I need to do the same thing with the denominator. And so for the denominator, I'm looking at numbers that multiply to when a is 1 and c is negative 24, so negative 24, and b is negative 2. So I need two numbers that multiply to negative 24 and add to 2, and so negative 2. So those two numbers would be negative 6 times positive 2, because negative 6 plus 2 is going to give us negative 6 times positive 4, because negative 6 times 4 is negative 24, and then negative 6 plus 4 is negative 2. So that means that this factor is going to be x plus 4 times x minus 6. And again, I could just use the product sum table because my a was 1. So notice that in b, when a isn't 1 in the numerator, that's going to mean that I have to use grouping in order to factor that numerator. So let's talk about the domain first, because we need to reduce like factors. So for the domain on this graph, or on this function, I'm looking for the values that would make the denominator 0. So remember that this means that x plus 4 can't be 0, and x minus 6 can't be 0, because I'm not allowed to divide by 0. So that means that if I were to solve each of these for x can't be negative 4, and x can't be 6. So that means that the domain is all real numbers except negative 4 and 6 for this problem. When I reduce, if I divide both the numerator and denominator by x minus 6, so x minus 6 over x minus 6 reduces to 1. And so that means that the result for this is simply x plus 7 over x plus 4. So the simplified expression is x plus 7 over x plus 4. The domain is all real numbers except negative 4 and positive 6. So B is asking us to do the same thing, except we have a little bit more complicated of a numerator. And so since the numerator has an a that is not 1, that tells us that we need to use grouping. So we're going to still do the product sum, but because a is 3, we're multiplying 3 times negative 9, which is negative 27. And then we need those numbers to add to b, which is negative 26. And so that means that we need to use negative 27 times 1, because negative 27 plus 1 is negative 26. So I'm just going to write this factorization here, and then I'll put it back into the fraction down below. So we'll do f of x down here a little bit. So 3x squared minus 26x minus 9. I need to use grouping, so I'm using the 27 and the 1 to split up the middle term, the negative 26x. So I'm going to have minus 27x plus 1x. So again, I know that I need to do that because 27 times 1 doesn't make negative 9. X, I can't just go straight into x plus or minus those values that I got from the product sum chart. So if I split these terms in half, now that I have 4, the common factor between 3x squared and 27, the greatest common factor is 3x. And so if I divide 3x squared by 3x, I'm left with x. And if I divide negative 27x by 3x, I'm left with negative 9. And so remember that the idea of grouping is that when I do the same thing, when I find the greatest common factor here, I should be left with x minus 9. Notice that's exactly what I have on this side. So this group is x minus 9. So that means that the greatest common factor is 1. So when I factor out their new common factor, which is x minus 9. So if I factor out x minus 9, I'm left with the GCFs, which are 3x plus 1. Okay, so that means that the factors of 3x squared minus 26x minus 9 are x minus 9 times 3x plus 1. If we look at our denominator, notice that we have a difference of two squares. X squared is a perfect square, and 81 is a perfect square. It has a square root of 9. So that means that x squared minus 81 factors to x plus 9 times x minus 9. So now looking at that, we can identify our domain. So if we just kind of eyeball the answers, so we knew that we set each factor of the denominator equal to 0 and solve. So notice when we had x plus 4 in the previous problem, our answer was that x couldn't be negative 4, and we had x minus 6 in the previous problem. Our answer was that x couldn't be positive 6. So that means that for our domain, the excluded values are going to be plus and minus 9, because negative 9 will make the first factor 0, and positive 9 will make the second factor 0. So that means that our domain is all real numbers except plus or minus 9. Then we can reduce our fraction. So we have a factor of x minus 9 and a factor of x minus 9 in the numerator and in the denominator. So if I divide those out, they leave me with 1. So the result is that f of x is equal to 3x plus 1 over x plus 9. And we know that the domain is all real numbers except for positive and negative 9 because of that factor that was reduced. So number 5 says simplify, but it's really a combination of everything we did in a lot of sections. So notice that for the first problem, we are doing multiplication. So if I'm simplifying something that is multiplied, the idea here is I want to factor and then reduce. We don't have to identify the domain, but the idea of domain would still apply, that my denominators are not allowed to be 0. So if I look at my numerator for the first fraction and I want to write that in factored form, I'm looking for two numbers that multiply to 12 and add to 8. And so those two numbers would be positive 2 and positive 6. So x squared plus 8x plus 12 factors to x plus 2 times x plus 6. My denominator is x minus 3. When it's linear, the most I can do is a greatest common factor. X minus 3 does not have a common factor between the two terms, so I'm just going to write that as is. The numerator of the second fraction is also linear. However, it does have a greatest common factor. So both of our terms are divisible by 2. So if I factor out a 2, I'm left with x minus 3. Finally, the denominator of the second fraction has an a value of 1. So we are looking for two numbers that multiply to negative 24 and add to 2. And so those two numbers would be a positive 6 and a negative 4. So x squared plus 2x minus 24 factors to x plus 6 times x minus 4. So again, if I was looking at domain, I would be looking at those 3 factors to find out what numbers are excluded. However, this question's not asking for that, so we can go ahead and reduce. So any factor in a numerator can be reduced with a factor in the denominator, because for multiplication, we're multiplying straight across. So these would all be in the same fraction. So I have an x plus 2 in my numerator. I do not in my denominator, so that's going to be a piece of my answer. I have an x plus 6 in the numerator of the first fraction, so if I divide by that, it also reduces with the x plus 6 in the denominator of the second fraction. The same thing happens with the x minus 3, so I can reduce that by x minus 3. So notice that our numerator is left with 2 times x plus 2, and our denominator is left with x minus 4. So when I'm multiplying, I factor and reduce. When I'm dividing, I turn it into multiplication so that I can factor and reduce. So I'm going to start a division problem by just rewriting the whole expression so that I turn it into multiplication. So I have x squared plus x over x squared minus 4. And I'm going to change division into multiplication and multiply by the reciprocal of the divisor. So I'm going to multiply by x plus 2 over x squared minus 1. So all that I did in that first step is turn it into multiplication so that I can then factor and reduce the same way that we did for part A. So x squared plus x has two terms. They both have an x in it, so that means that we can factor an x out. And so we're left with x plus 1 if I divide x squared plus x each term by x. The denominator of this is x squared minus 4. Those are both perfect squares, so that means that this factors to x plus 2 times x minus 2, because the square root of x squared is x, and the square root of 4 is 2. X plus 2 is linear, and there's no common factor, so I need to just leave it as x plus 2. Finally, x squared minus 1 is also a difference of squares. So 1 is a perfect square, x squared is a perfect square, so that will factor to x plus 1 times x minus 1. So now looking at our factored form, we can identify what factors reduce. So our numerator has an x. Notice nothing else has an x. So I know that that's going to be a piece of my answer. X plus 1 reduces, as does the x plus 2. So our numerator, we're left only with x, and our denominator is left with x minus 2 times x minus 1. Okay, so that's multiplying and dividing. It's essentially factor reduce. For division, you have to turn it into multiplication by multiplying by the reciprocal first. The next 4 problems have to do with the adding and subtracting. So C and D are compound fractions, so we have fractions inside of fractions. Remember that our goal for these is to create our numerator so that it's one fraction, and the same with the denominator. So we're going to need to add or subtract, and then we can look at the fraction as division. So for this first one, we have 10 plus 2 over x. Since the 10 doesn't have a denominator, I'm going to put it as 10 over 1. Same thing with the 3, so I'm going to make that 3 over 1. We have 3 over 1 minus 4 over x minus 1. Whenever we're subtracting, it's best to change it to addition and move the negative up with the numerator and change the signs of all the numerator if there's more than one term, just so you don't lose that negative when you have to multiply later. So looking at just the numerator, notice that I have one denominator of x, one denominator of 1. So I need to multiply the first fraction by x over x so that they will both have a denominator of x. That's going to make my numerator 10 times x, so 10x plus 2. I need to do the exact same thing in the denominator where I have 3 plus negative 4 over x minus 1. So since the denominator is x minus 1, I need to multiply the first number, since that doesn't have a denominator, by x minus 1 over x minus 1, so that I can have the common denominator of x minus 1. So what I'm going to do with this is I need to distribute the 3. So I'm going to have 3x minus 3, and then I have that minus 4 from the original problem. So let's just clean this up. So this gives us 10x plus 2 over x over 3x minus 7 over x minus 1. So remember that when I'm dividing, and that over is really the same thing as division, I want to take this and take my numerator. So my numerator is 10x plus 2 over x. And instead of division, I want to change it to multiplication by writing the reciprocal of my denominator, meaning I want to write this as x minus 1 over 3x minus 7. So I would try to reduce this if possible. So what I want to look at is, can I factor anything? And I can factor this numerator 10x plus 2. So I can factor out, it's not a 5, I can factor out a 2 because 10 and 2 are both even. And that leaves me with 5x plus 1 there instead. So instead of 10x plus 2. However, I don't have a 5x plus 1 anywhere else, nor do I have a 2. So that's not helpful in terms of reducing. So for my answer, I'm just going to write everything multiplied together. Remember, we don't actually distribute these. So I have 2 times 5x plus 1 times x minus 1 over x times 3x minus 7. Okay, so this compound fraction simplified into a single fraction is that expression. Part D is similar to part C, except that our numerator is actually just a single piece. So this x minus y in the numerator, I can't simplify that because there's no fractions, so no denominators, nothing for me to combine. However, 2 over x plus 7 over y, I do need to write that as a single fraction. So since they each have a totally different denominator, x and y, I have to multiply the first fraction by y over y so that my denominator will be x times y. And I need to multiply the second fraction by the first fraction's denominator, x over x, so that my denominator again is x times y. So the numerator, x minus y, we can't do anything to simplify. This new fraction in our denominator we're going to be able to combine because they both have a denominator of x times y. So if I multiply 2y plus 7x, that's going to give me a single fraction in the denominator. So remember that I'm thinking about this as being division. So I'm taking and dividing x minus y by 2y plus 7x over xy. So I've got x minus y times, if I change this to multiplication, the reciprocal x times y over 2y plus 7x. And so what I want to ask myself as I'm doing this is, can I factor 2y plus 7x, which 2 and 7 do not have common factors. So that means that the result of this compound fraction is xy times x minus y all over 2y plus 7x. Parts E and F are subtraction and addition. So when I'm adding and subtracting, I have to do similar to what we just did in the compound fraction, where I need to find a common denominator. So if I have 7x over 2x minus 3, I want to try to factor the denominator, which isn't possible. So I'm just going to put it in parentheses to remind myself that that's a unit. Minus 5 over x plus 2. So since it's subtraction, let's change it to addition by multiplying the numerator by the negative. So we're moving the negative up with the numerator. So since our denominators are both totally different, that means that we need to multiply them together to create the LCD. So the first fraction we need to multiply by x plus 2. And the second fraction needs to be multiplied by 2x minus 3 over 2x minus 3. Remember that when we're adding and subtracting, we leave our denominator factored because our ultimate goal is to be able to factor the numerator and reduce if it's possible. And so for this one, I have to distribute 7x into x plus 2. So that's going to give me 7x squared plus 14x. And I need to distribute negative 5 into 2x minus 3. So that's going to give me negative 10x plus 15. So then I want to combine like terms in the numerator, which gives me 7x squared plus 4x plus 15 over 2x minus 3 times x plus 2. So for this, I would want to check to see if this is factorable. So I want to look at doing a product sum for the numerator. So I'm going to multiply 7 times 15, which is 105. And that would need to add to 4. So if I notice that everything is positive, so I have to have a positive 105, which would mean, for example, if I was multiplying 7 times 15 and I added those two together, that will give me a number that's a lot larger than 4. And I know that if my sum is smaller than, say, my A, there's no way that I'm going to have a number, be able to add 7 to something and it become a number that is smaller than that. So this is going to be a prime factor. So this is just our result. So 2x minus 3 over x plus 2 is our denominator, and 7x squared plus 4x plus 15 is the numerator. F is asking us to add. So in this case, we can factor our denominators. So in E, we had two totally different denominators. So we were just multiplying by each other's denominators to simplify. For E, we want to, for F, we want to factor the denominators to identify our common denominator. So if I have x squared minus 7x minus 8, I'm looking for two numbers that multiply to negative 8 and add to negative 7. So those would be x minus 8 and x plus 1. In the denominator of the second fraction, I have x squared minus 3x minus 40. So I need two numbers that multiply to negative 40 and add to negative 3. So those would be x minus 8 times x plus 5. So if I look at these, they both have an x minus 8. And so my LCD is going to be x minus 8 times x plus 5 times x plus 1. Excuse me. And so if I rewrite this with room to multiply, I have negative 2x over x minus 8 times x plus 1. This denominator is missing the x plus 5. So I'm going to multiply this by x plus 5 over x plus 5. Plus, I have 4x over x minus 8 times x plus 5. This one's missing the x plus 1. So I'm going to multiply the numerator and denominator by x plus 1. So now that they both have the same denominator, which is x minus 8 times x plus 1 times x plus 5, I can't distribute the numerators to simplify. So I can multiply by negative 2x, the x plus 5. So that's going to be negative 2x squared minus 10x. And then I can multiply 4x times x plus 1. So that's going to give me 4x squared plus 4x. Which if I combine like terms, 4x squared minus 2x is giving us 2x squared. And then negative 10x plus 4x is minus 6x over x minus 8 times x plus 1 times x plus 5. So I can factor 2x squared minus 6x. So my denominator is still x minus 8 times x plus 1 times x plus 5. Over my numerator, I can divide both terms by 2x. So I'm going to factor out the greatest common factor of 2x, which will leave me with x minus 3. So notice that x minus 3 is not in my denominator, so this does not reduce. So this is the simplified form of the problem for part F.